In the vast expanse of the night sky, amidst the myriad of twinkling stars and distant galaxies, there exists a celestial beacon that has captured the imagination of explorers, sailors, and dreamers for centuries. This guiding light, steadfast and unwavering, is none other than Polaris, the North Star. But recently, there have been intriguing reports about our guiding light in the night sky. Something peculiar is happening to Polaris, and it has astronomers buzzing with curiosity. So, what's all the recent hype about? Get ready to embark on a mesmerizing cosmic journey to the North Star and discover what researchers are now saying about the strange and unknown phenomena affecting Polaris. Logo, Polaris, also known as Alpha Ursae Minoris or Alpha Mi for short, is a moderately bright star, ranking as the 48th brightest in the night sky. Its slightly yellowish hue and prominent position near the celestial North Pole have made it a vital tool for navigation for centuries. Its remarkable location allows it to be a near-constant point of reference. Polaris aligns almost perfectly with the Earth's axis of rotation. Imagine the Earth's axis as an invisible line running from the North Pole to the South Pole. Polaris is positioned very close to this line, so it remains nearly stationary in the northern celestial hemisphere, while other stars appear to revolve around it. But the Earth's axis doesn't spin like a perfect top. Instead, it undergoes a slow, gradual wobble known as axial precession, caused by gravitational interactions with the Sun and Moon. Over approximately 26,000 years, the Earth's axis traces a circular path, much like a spinning top losing its balance. As Earth experiences axial precession, the orientation of its axis changes relative to the background stars. This results in the shifting of the North Star over millennia. While Polaris is our North Star today, in about 13,000 years, Vega will take its place. This slow movement of the celestial pole is termed stellar precession. Historically, around 3000 BC, a faint star called Thuban in the constellation Draco served as the North Star during the era when the Egyptians built the pyramids. Polaris became our North Star around 500 AD and will continue to be so until around 2102. After that, it will start moving away from the North Pole but will remain the closest star to it until 3000 AD. If you're wondering how to find the North Star, it largely depends on where you are on Earth. Some regions may not have a clear view of it. If you've been following our channel, you're likely familiar with constellations, which are groups of stars forming recognizable patterns. Let's become experts in finding these constellations and, thereby, the North Star. Asterisk. There are a few methods to locate Polaris in the night sky. The first involves finding the constellation known as the Big Dipper. This constellation, shaped like a ladle or scoop, is relatively easy to spot. Look for the two stars at the end of the cup of the Big Dipper, opposite the handle. These are known as the pointer stars. Draw an imaginary line from the star Merak through Dubhe, extending it about 5 times the distance between these stars. You should find a bright star twinkling in the night sky. If you're still unsure, check to the left of this star to locate the constellation, the Little Dipper. The Little Dipper's handle has 3 stars, and Polaris is the star at the end of this handle. Keep in mind that the Little Dipper might appear upside down or as a mirror image of the Big Dipper. Confirming your findings, you'll have successfully located Polaris, the North Star. For those in regions where Polaris is not visible, remember that it dips below the horizon as you move southward from the equator. At the equator, it's right on the horizon and becomes invisible further south. In the southern hemisphere, Polaris cannot be seen at all. Here's something fascinating that you can't observe without a telescope. Polaris is part of a multiple star system. The primary star, Polaris A, is a supergiant with about 4.5 times the mass of our Sun and a diameter of nearly 28 million miles, 45 million kilometers. Polaris A is a Cepheid variable star, known for its pulsating behavior. This pulsation causes variations in its brightness, making it a standard candle for measuring cosmic distances. The 2 smaller companions in this system are Polaris B and Polaris AB. Polaris B orbits Polaris A at around 2,400 astronomical units, while Polaris A flat orbits at about 18,000 astronomical units. Observing these companions requires a powerful telescope, but they offer invaluable insights into the dynamics of stellar systems. Recently, researchers have been grappling with some unusual findings regarding Polaris. There have been difficulties in precisely measuring its distance from Earth. This challenge arises because Polaris seems to defy some of the stellar models astronomers use. Astrophysicists use methods like the stellar evolution model to estimate the mass, age, and distance of stars. This model examines a star's brightness, color, and pulsation rate. For Cepheid variables like Polaris, this method should be straightforward. However, Polaris's pulsation periods, which were consistently lengthening by about 4 to 5 seconds annually until 2010, have recently started to decrease. One hypothesis is that the orbit of Polaris B could be influencing these changes, as it orbits Polaris A every 30 years and might disturb the Cepheid's outer layers. Another intriguing theory suggests that Polaris might have once been a binary star system that collided, rejuvenating the star. However, binary star collisions do not fit neatly into current stellar evolution models. Yet, in the cosmos, anything is possible. An exciting recent discovery came in 2022 from Queen's University in Kingston, Canada. Researchers found that Polaris has a remarkable magnetic field. This magnetic field could explain the peculiar pulsations of the star. Just as Earth's magnetic field influences various phenomena, A star's magnetic field can affect its winds, internal structure, and rotational speed. Understanding Polaris's magnetic field could provide crucial insights into the behavior of Cepheid stars and, more broadly, the mysteries of the universe. The team is currently analyzing data and mapping the star's magnetic field as it rotates into view.